Welcome to True Projects. In this video, we are going to explain about the project that is text data augmentation techniques for word embeddings in fake news classification. Before getting into the execution, first let us understand what is the project about. In tasks like fake news detection, the biggest challenge is that often we don't have enough diverse data to train the model effectively. Let's say we are working with a small or imbalanced data set. It's like trying to learn a new language with just a few phrases. The model struggles because it doesn't see enough variety to generalize well. So this is where text data augmentation comes into the play. It becomes essential. It is a way to expand the data set by tweaking the existing data. So we will take the existing data into consideration and we will tweak it, then create a more examples without needing new data. While technically, like these are commonly used in computer vision, they are still not widely explored in natural language processing. So they are not yet that much explored in natural language processing. And in NLP, subtle changes in languages like replacing a word or altering sentence structure can make a huge difference. So take for example word to vec, which is word embedding model. It relies heavily on input data to understand the relationships between words. If the data is limited, word2vec fails to capture these relationships effectively, leading to model that doesn't perform well on the real world data. So the real issue is that without enough linguistic diversity in our data sets, the models can't generalize and end up with lower accuracy in classification tasks like fake news detection. This is exactly what we are trying to solve with the data augmentation. So this project focuses on testing how well different data augment techniques improve fake news classification. Specifically, it evaluates three methods, that is synonym replacement, that I mean where words are swapped with their synonyms. Coming to back translation, it translates text to another language and back. Reduction of function words where less significant words are removed. The idea is to see how these techniques affect the quality of training data and ultimately improve the model performance. To do this, we have incorporated the dataset that is well-fake dataset. So it is used as the base, and these techniques are applied. That means synonym replacement, back translation, and reduction of function words are applied to this dataset and create variations of the data. Then word to vec skipgram models are implemented. They are trained to generate word embeddings, essentially numerical representation of the words based on their context. Their embeddings are fed into the machine learning classifiers like random forest, logistic regression, Bernoulli naive Bayes, and support vector classifiers. Finally, the project measures of these classifiers using the metrics called accuracy, precision, recall, and FN score. So first, what do we do is we train well-fake data set with all these different techniques. After that, we do word embedding using this word to vec skip grams, and then do the classification using this random forest logistic regression, Bernoulli naive Bayes and support vector classifiers, and evaluate them using accuracy, precision, recall, and F1 score. This is all about the proposed system. Moving to the extension part. To make our fake news classification system even better, we have incorporated the XGBoost model as an advanced algorithm that is highly accurate. Think of XGBoost as a team of decision trees working together, where each tree learns from the mistakes of ones before it. This process ensures that model becomes increasingly precise with every iteration. It is particularly effective because it doesn't just rely on one tree, but combines the strengths of many, prioritizing the ones that make the best predictions. To make the front end more interactive, user-friendly interface has been built. That too by using the Flask framework. So by using Flask framework, we have developed front end. This would let users directly test the classification system through an easy to use interface. On top of that, we have implemented user authentication mechanism. So this ensures that only authorized users can access it. This way, the system becomes not just powerful in terms of performance, but also accessible and secure. Moving to the implementation of the project, we have followed the steps in the flow of work to implement this project. Let's see what the first step is. So first, what we have done is we have loaded all the necessary libraries like NumPy, Pandas, sklearn, and Flask, along with any other required for data processing, augmentation, and model building. Coming to the next step. Here we analyze well-fed dataset to understand its structure, distribution, and contents, focusing on the text data and associated labels. The next step we have implemented is text pre-processing. Here we remove punctuation, stop words, and non-alphabetic tokens, and we apply stemming and lemmatization to standardize the words. Coming to the next step, that is the proposed part of the project, that is data augmentation. So here we apply back translation, that is, we apply back translation for text variability by translating to the another language and back to the original language. Coming to synonym replacement, here we use synonym replacement to substitute words with their synonyms, that means similar words. Coming to the reduction part, here we perform reduction by removing less meaningful words. Then what do we do is we convert pre-processed text to X and labels to Y into a NumPy array format for compatibility with the machine learning models. And then what do we do is we extract features using word to X, skip gram, and the similar technique to generate word embeddings from the clean data. Then we split the data into training and testing sets. Training set is used to train the models, and testing set is used to evaluate the performance of the models on unseen data. Then we define multiple machine learning models like random forest, logistic regression, etc. And all those models are trained on the data set. So we train all the defined models using training data for optimizing best results. And we evaluate all of them using accuracy, precision, recall, and FN score, and we compare them using the graphs. Coming to the part of front end, we build web interface using Flask, incorporating user registration and login with SQLite for secure access. And in the front end, users will be able to give the input as a text, and that will be pre-processed at the back end. It will be fed with the trained model, and finally, outcome will be displayed through front end. Moving on to implement this project, we have used these algorithms. So we have used these algorithms for classifying the fake news. We have used support vector machine, Bernoulli naive Bayes, logistic regression, random forest, and extension XGBoost model. Coming to the requirements, to implement this project, we need basic requirements, which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So now it's time to execute. To execute, we need to open the code folder which contains source code files. So let us open the code folder of the project. So these are the source code files in the code folder of the project. Let us open the dataset folder and see what is in it. So this is the dataset that we have used in the project to train all the models for detecting fake news. It is being loaded. Just wait for a while. Until then, we'll understand the other folders. So here we have model folder that contains the algorithm information that will be loaded into the project code during runtime of the application. And here in the static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Here in the templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here in this test news folder, let's open it. We have 5 test cases. These we will be using them in the front end to detect the fake news. There we will be classifying fake news and genuine news using these test cases. Let's get back. And this is the notebook file. This file is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. Now I think dataset has been opened. So this is the dataset used in this project to train all the models that will be able to classify the fake news. So here we have 2 kinds of class labels. One represent there is fake news and 0 is for real news. Let's close this. Now get back to the code folder and copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the command prompt. So open the command prompt. Give the command cd followed by the space. Paste the copied path. Now click on enter. So here, if you observe, current directory is changed to the code folders path. Now we have to compile the app.py file. So give the command python space app.py and now click on enter. So this command will execute Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will be hosting the web application at the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Now click on register and get registered if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So here you can see choose file button, right? We need to click on that for uploading the text files. So click on that. So these are the individual text files that we will be uploading for fake news prediction. Let's upload the first file. Click on open and now click on upload. So the given file will be pre-processed at the backend, then train model will be giving us the prediction. So this is the text that we have uploaded. So this is the text and here we have the prediction as real. So this means that the uploaded text is real. Now let's check with some more test cases. Click on choose file. Let's try with the second one. So this is the uploaded text and here we have the prediction that as fake. So all the text that we upload will undergo under the data augmentation techniques that is proposed, that is back translation, synonym replacement, and reduction. Let's try uploading some more images, some more text files. Click on choose file. Let us upload the third one. Click on open and now upload it. So this is the text that we have uploaded. And here we have prediction as fake news that has been classified. Let's try uploading last one more file. Let's upload the fifth one. Click on open and now upload it. And here we have the prediction that it has been predicted as fake. Now let's check with the graphs. Click on graph. So the first graph which we have is the sample outcome graph that shows the class distribution of the classes that we are going to predict in this project. Here on x-axis we have fake and real newses, that is fake and real news classes, and here on y-axis we have count of each particular class. Here we have extension models, accuracy graph for all the original SR corpus, FWD corpus, that is BT corpus, that is all the data augmentation techniques that we have implemented, and that is represented in the box plot. Here on y-axis we have accuracy, and on y-axis we have different augmentation techniques that we have considered. And this is the accuracy comparison graph. Here on x-axis we have accuracy scores and on y-axis we have all the algorithm names that are used to train the model so that they will be able to classify the fake news. And this is the precision comparison graph. This is the recall and this is FN score. These are all the metrics used to evaluate the models. Now click on logout. In this page, just by giving the text to the system will augment that data and then it will give the prediction. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.